All right, so we're going to work a couple problems from our homework that you had for tonight's worksheet 1.5. And the first thing we're going to do is we're going to look at number 4. Okay, this first column that's blank here is where we're going to do the table. So I'm just going to get it laid out, and then we'll decide here in a minute what our independent and dependent or domain and range values are. Quantities are. So let's look at the problem here. This one has meaning to it, so we have to be careful about what our domain and range are. Okay, unlike if it were just a regular function where we could say all real numbers, this one has some meaning to it. It says here Xavier has $12. He wants to buy oranges which cost 75 cents a piece. So we need to look at what two quantities or what two values are being compared or talked about, okay? And it says here that he wants to buy oranges and that they cost 75 cents a piece. So there's a total cost involved here. And if you remember from the table in our classroom, the total cost usually represents the range. So we're going to put here the total cost, because remember guys, the range is also our y values. Now what is he wanting to buy? He's wanting to buy oranges. So the number of oranges he purchases will determine the total cost, okay? The total amount he has to pay at the cash register. Okay, so let's look here. Let's think about this. We know we cannot use negative numbers for oranges because we can't have negative oranges. Half oranges, he can't purchase half of an orange. So the first value that makes sense for this situation is 0. If he buys 0 oranges, he pays a total of $0. Okay, we can continue on. Here we're not going to do a half orange because he can't do that, but he can buy 1 orange. Then he's going to pay 75 cents. Okay, we're building our table right now. If he purchases 2 oranges, he's going to pay 2 times 75 cents, which is $1.50. And I can keep going. He can buy 3 oranges, which would be 3 times 75 cents, which would be $2.25. Okay, and we can keep right on going. Now, this sentence right here tells me that there's a limit to what he can buy. The most he can spend is $12. So somewhere down here, I'm going to have a range of $12. Okay, that's the most he can spend, or a range value of 12. Now what we have to do is find the number of oranges that he can buy for $12. So in your calculator you can take, well, if I have $12, divide that by 75 cents, that will give me the fact that he can purchase 16 oranges. Okay, and he can purchase any whole value up to that point, but he has to stop at 16 because all he has is $12. Okay, so we've just set up the table that describes this situation. So now we're going to go to our domain. Remember, the domain are the x values, and in this case there it's the independent quantity, which is the number of oranges. Okay, and I start by drawing my bracket, and I'm just going to write the values from the column for my number of oranges, my independent quantity. So he can buy 0, 1, 2. Okay, I've established a pattern, so I'm going to dot, dot, dot. The most he can purchase is 16. So there's my domain representation for this situation. Now the range, again, I'm going to look at the total cost column. Okay, if he purchases 0 oranges, he spends $0. If he purchases 1, it's 75 cents. 2 is $1.50. Okay, I've established my pattern, so dot, dot, dot. The most he can spend is 12, so that's the upper bracket for my range values. This kind of function is a discrete function because I can count what I'm purchasing. Okay, so that's discrete. The graph representation, when I do this graph here, it's going to be just in the first quadrant because I can only have positive values for oranges and the total cost that I'm going to pay. So all I'm going to do is draw my first quadrant. The x-axis can be titled number of oranges because that's our domain value or our independent quantity. And the y-axis, we're going to label the total cost. All right, it is discrete, so that means I'm going to use dots on my graph. And I'm going to pull the points right from my domain and range, or I could even pull them from my table. Okay? If I have 0 oranges, I will spend $0, so that would be the first point I have. If I have 1 orange, I'm going to spend 75 cents. Notice I'm not concerned about putting the hash marks on my graph. It's okay for right now. If I buy 2 oranges, $1.50, and so on and so forth. It's just going to continue on like this, and that describes discrete data for this situation. And you're all set with number 4. Okay. All right, let's actually go back to number 1. Well, actually, no, just kidding. We're going to go to number 5. Okay. Number 5 here is a situation, so there's meaning associated with our domain and range and with this function. So we have to be careful about what we label, or what values we give for our domain and range. There's only certain ones we can do. Okay, we are going to make a table, so I'm going to sketch that in here first. Then I'm going to read my situation and see if I can determine what the independent and dependent variables are. Okay, it says the Conrad family is hiking uphill from a campsite 3,000 feet above sea level to the summit of a mountain 8,000 feet. They climb an average of 500 vertical feet an hour. Okay, so I see hour there. That tells me there's time involved. And if I remember from my chart, time is associated with the independent variable, which is the domain, which is the x values, which is the input. So I'm going to use that knowledge that I have, and I'm going to label number of hours as my independent variable. Okay? Now, the number of hours determines what? And if I read through here, it says here that they climb 500 vertical feet each hour. So my number of hours determines the height that I'm at, or the height that that family is at. Okay, the height of that they are on their mountain. Okay, so when they start out at 0 hours, when they start out at a height of, and it says here they start from a campsite that's 3,000 feet above sea level. So they start at 3,000 feet. Okay. Now, can they go a half an hour? Well, they sure can. Okay, time is measured by half hour. So if they went a half an hour into their trip, they would be 250 feet past where they started. Okay, because this says 500 feet for each hour. But if they're only at a half an hour, that means 250 feet. So this would be 3,250 feet. Okay, if they were at an hour, they would be at 3,500 feet. Okay, so I'm going to continue on. If they were at, let's say, 2 hours, I know that for every hour that goes by, they go 500 feet, so they would be at 4,000 feet. Now I know that I have to stop at 8,000, so I know that the highest they can climb is 8,000, so I'm going to put that down here. Okay, and if I continue on and on and on, and think, well, after every hour they've gone another 500 feet, I'm going to find out that after 10 hours, they've reached this summit of 8,000 feet, the summit of the mountain at 8,000 feet. Okay, so I've got parameters or guidelines for my domain and range. So I'm going to look right here. We talked about this in class. We talked about how time is something that is measured. I can have a half of an hour. I can have a quarter of an hour. I can have a 1/12 of an hour. I can have all of those values. So this would be considered continuous, a continuous function. So that means my domain and range are going to represent that. Okay, I cannot list all the possible times between 0 and 10 hours. So I'm going to say my domain can be represented by 0 at the start. The max they're going to go is 10 hours. And all of the x values are going to be in between those time frames. Okay, this tells me that I am talking about 0 to 10 hours inclusive. That means all the time possibilities in between 0 and 10. I have the same for range. I can measure 3,000.25 feet. I can measure 4,000.333 feet. Okay, I can measure all of those variables or all of those measurements in between there. So I'm going to indicate that on my range by saying the minimum range they have, or where they started, is 3,000 feet. The max they climbed was 8,000 feet. I know they stopped there, so that's the highest. These are my Y values because it's range. And it's inclusive. That means it contains all of those numbers in between 3,000, 8,000. Now when I sketch my graph, I do have to consider the fact that I'm not going to go negative amounts. So I can still just draw my first quadrant to represent the positive measurements. My x-axis is going to have a label of hours. And my y-axis is going to be the height. Alright, that was kind of messy. I know you guys can do a little bit better than that. Okay, I know that at 0 hours they started out at 3,000. So let's just say we're about right there. Okay, I know at half an hour they're a little bit higher, and so on. At 1 hour they were 3,500. Okay, I also know this is continuous, so I'm going to draw my graph like that, and I know that it has to stop at, let's say this is my 10 hours right there. Okay, so that would be a descriptive graph, or a basic sketch of the graph that describes this situation.